Imagine if every wire in your home was exposed. Every power line, every internet cable. If something goes wrong, how do you even begin to fix it? That's what happens when your code lacks encapsulation. Every part of your system can see every other part. And this leads to chaos. But the opposite, over-encapsulation, can be just as bad, making systems untestable and difficult to untangle. In this video, we're going to fix that. I'll show you how to use encapsulation to create scalable, adaptable software while avoiding some common mistakes that can turn into a nightmare. So if you've ever struggled with debugging code that behaves unexpectedly, then this video is for you. So let's dive in. Hello world, I'm David Scott Bernstein and welcome to The Passionate Programmer. In this video, we're talking about encapsulation, one of the most powerful yet misunderstood qualities in software development and design. Encapsulation is simple. Hide how you do something. Expose only what you do. But it can be challenging in implementation. This gives us the freedom to change our implementation later without breaking the entire system. Encapsulation is more than making your data and your methods private. It's hiding how you do something and only showing what you do. This is key because without inside and outside, without hiding implementation details, everything becomes a mess. You probably know this because even a small program without encapsulation can be a bit tricky to manage and work with. Large programs become nearly impossible. And we waste so much time trying to figure out in big code bases what affected this variable or how this state changed. There's many other things that we can hide beyond state. We can hide how we do something. Design patterns help us hide different aspects of our program. It kind of is strange to say this because I'm a person who is into full disclosure. I like to share my thought process. I like to share my videos. I like to share my ideas. And so the idea of not sharing is kind of strange to me. But remember, we're talking about the virtual domain of a computer. And so I want to take care of my objects. I want to treat them well. And one of the things that I want to do with my objects to treat them well is to hide unnecessary details. Why should I concern, a file system object with the GUI? I shouldn't. So I'm doing this, I'm using a need-to-know basis for my objects because that's the kindest thing I can do to them. Encapsulation is essential for modular testable software. We want to be able to test each component in isolation. I think of two different kinds of encapsulation, what I call conceptual or design level encapsulation and implementation or code level encapsulation. Most people think about, when they think about encapsulation, they think about code level encapsulation, making data private and hiding details in the code. And that's very important. But conceptually, we also want to hide. When we do this, it gives us the freedom to change those details later without breaking a bunch of code. Encapsulation enables scalability in code and vastly supports refactoring of code. At the most extreme end, encapsulation is complete darkness, nothing, and you don't want that. At the other side of the spectrum, it's total transparency. You can see everything, and you don't want that either. And so it's a dial that you want to dial in at the right level, where you're hiding the details but exposing the interface. So let's talk about the two kinds of encapsulation, over-encapsulation and under-encapsulation. So let's start with what most people know, which is under-encapsulation. Global variables are shared across the system, and that's perhaps the least encapsulated form of data. If it can be changed from anywhere, then likely it will be changed from anywhere. And it makes it very hard to track down and create systems around change. Functions modifying external state without any restrictions can also lead to encapsulation nightmares. That's all about under-encapsulating. But what about over-encapsulation? That's also bad. If I instantiate the service and then use it to the outside world, it looks like They're the same thing. I can't break them apart to test them independently. And when I have many dependencies, it basically means I can't test anything because everything is so intertwined. Very, very important, because if I can't test it, I can't validate that it works under all conditions. Software has the nature of being influenced by things at a distance. And so if we don't have the ability to change code, if things are tightly coupled, then basically it becomes this one big ball of mud, and it's very hard to do anything with. When we create steep inheritance hierarchies, it can also obscure our data and make it harder to access at lower levels. Excessive layers of indirection without a clear purpose can cause encapsulation issues. Encapsulation is about control, not restriction. Too little encapsulation means that our code becomes unpredictable and difficult to work with. Too much encapsulation means that our code is hard to extend and to validate. We can encapsulate state, we can encapsulate relationships, we can encapsulate many other things, not just data. We can encapsulate the order of steps. That's called sequence. We can encapsulate the number of steps that we do. Maybe in one situation we do step 1, 2, and 3, but in a different situation we do steps 1 and 3 and skip step 2. That's called cardinality, the number of steps that we do. So we can encapsulate a lot of different things, and design patterns are really there for encapsulation. I think that the job of a great software developer is to get the job done, whatever it is that they're doing, and encapsulate as much as possible. Because when we encapsulate, we have the freedom to change things without breaking other things. This becomes very valuable if we want our systems to evolve and grow. Here are some techniques for good encapsulation. Every field should be designated as private. And if some other entity needs access to it, then you can provide some methods to access the field. Expose stable interfaces. And when I say interfaces, what I mean is method signatures. So you have a method that you call with these parameters. Those are the parameters that that method consumes. When you have globals, when you have singletons, you have things that are being consumed that are not part of your method signature, and it's hidden. When I do this, I'm forcing you to read my code. You can't just look at my method signature. You can't just go to my header file and see what I'm doing, see where all my dependencies are. And that's the other reason that I really hate global variables. They hide the truth. If we expose too much, there are patterns that can help us. Adapter, facade, things like that. Favor dependency injection. And I'm sure you're probably familiar with dependency injection frameworks like Spring. We're just using it without the framework. We're just doing it manually. So instead of newing up some service and then using it, have some other entity pass you the service, have some other entity new it up for you. Then you don't have to know what that specific type is. You can hold it in an upcast. That means that you can add new variations in the future without breaking that code. And that's a really common trick in OO. It's a key to being able to use OO correctly. Let's be honest. Most of us have inherently messy code. And when code is hard to read, it's also hard to change without breaking things. I put together the Clean Code Refactoring Guide as a step-by-step resource to help you transform messy, hard-to-maintain code into something clean, structured, and scalable. It includes before and after examples, code smells to watch out for, and actionable refactoring techniques that you can use right now. Want a copy? You can download it for free as part of my Clean Code Toolkit. The link is in the description. It has other resources as well to help you write cleaner, more maintainable code. So check it out. Have you ever used a device with so many options that you can't figure out how to use it? Bad encapsulation creates the same problem in software. It overcomplicates things, makes them rigid and frustrating to work with. When we spread business logic across multiple classes, it becomes really hard to track and to change. When we have hard dependencies between unrelated classes, it limits reusability and makes testing a nightmare. We want our unit tests to be accessible by a single click and we can run all of our suites of tests without any problem. I like to run my tests unconsciously. I very often will find myself hitting that green bar and watching my tests pass just randomly throughout the day because it's kind of like a shot of espresso. It kind of gets me going to see the green bar, you know? Let's look at some code. Here's an example of some poor encapsulation. We're exposing implementation details. Here, order service directly depends on the database instance. That means we can't change it without changing how we store information. This is poor encapsulation. Here's the after. Order service now depends on a repository. Having a repository layer abstracts out the database so that we can swap it out if needed. Now order service depends on an abstraction, order repository, and not a concrete class. This means that we can swap implementations without breaking anything. Encapsulation also improves testability. When we hide implementation details, it increases the flexibility of our code. When we decouple storage logic from business logic, it becomes a lot easier to understand what's going on. A company I worked with had an API that exposed its entire database schema. Every change broke multiple clients. By introducing encapsulation through a proper API layer, we reduced breaking changes by over 80%. And this made onboarding new developers significantly easier. And testing also became far easier. Encapsulation is essential, but to truly master clean code, you also need to ensure your code is assertive, making decisions instead of asking too many questions. In the next video, we're going to break down assertiveness, why it matters, and how to write code that's clear, direct, and robust. So if you want to make your code self-sufficient and easier to work with, then watch this next video now. Subscribe and hit the bell icon so you don't miss any new videos when they come out. Until then, happy coding.